Hello, my name is Colin Swords, and along with my partner Ben Palmer, this is our Arduino design project for Professor Elger's 223 design class. The style of presentation we are using is called Pachachka, which incorporates images while showing some of the finer details of the design. Our goal is to design a product using the Arduino to control input and output function. Using Arduino, we developed a scale to accurately measure weights with variable inputs. For example, most common scales are used by adding or subtracting amounts until a specific weight is obtained. However, this scale is different because instead of finding a weight to obtain an output for the item, the scale is pre-programmed to know what the user is looking for at certain input weights. The Arduino is programmed with intervals that are connected to 7 LED lights. As the pressure is increased on the sensor, the more lights go up. How many lights go up and what color are all determined by how the unit is programmed by the user. This can be used for a multitude of purposes, such as reloading for recreational shooters or military personnel, or by chefs who want to know exactly what the recipe is going to taste like with a certain amount of ingredient. This kind of precision is invaluable when combined with the efficiency it provides. Our product strives to challenge the status quo of same old technology is good enough, and it drives us to provide a higher standard to the customer. Along with a product that is brilliantly designed and easy to use, we demand of ourselves products that are of the highest quality. Dealing with products like ammunition requires that our work is flawless, since these items come with very high consequences. There is no room for error whatsoever. What we enjoy experiencing the most, however, is the satisfaction of designing a killer product that reduces hassle and improves efficiency in a real-time manner. Our product will reduce time spent on unnecessary and inefficient means of quality assurance. Older products come with guarantees of incredible accuracies, but what does that matter if you don't know what your outcome is? For people who know what they want with amazing accuracy and little wasted time, this is a product sure to not disappoint. In addition to the practical side of our project, we were able to incorporate a technical representation of our prototype. As you can see in the above photo, the Arduino starts out with 7 individual pins that connect the LEDs to the power and ground. LEDs, also known as light-emitting diodes, are just simple lights you might find in your flashlight or the headlights in your car. They are located on the digital side of the Arduino and must be individually programmed to the user's desire. Between each pin and the breadboard is a resistor, which limits how much current goes in. Each pin has a wire that connects the digital to the breadboard, allowing the LED lights to function. Also on the breadboard is a small pressure sensor that also has its own resistor hooked up to it. The 9-volt battery supplies power to the grid, which is transferred over to the breadboard. This in turn is sent through a resistor to each pin as well as the pressure sensor. This is what separates our design from many others. Our product is programmed to inform the user of when he or she is at an ideal measuring point. Now again, these measurements are made to reach desired outcomes, not to specifically determine them. The scale comes pre-programmed to whatever parameters the customer has specifically requested. For example, a munitions technician might order the scale program to inform him when his powder charges will reach certain velocities with the predetermined loads. With an older scale, he would have to manually weigh the amount of powder and determine after firing the round what the performance capabilities of his charge were. Now he simply adds powder to the scale until it lights up, informing the user that the weight is sufficient. As with any project, we ran into our share of problems throughout the design process. We blew out a few LEDs and had several bad connections, but overall it came through well. The toughest obstacle was calibrating the pressure sensor to our desires with the LEDs. We wanted each LED to turn on at a certain pressure, although the pressure sensor is coded by electrical output, not pressure itself. The more pressure placed on the sensor, the more current is drawn from the 9-volt battery. It was frustrating seeing all the LEDs come on at one time, as it was seeing them not all come on in one sequence. Most of these problems we solved by going into the Arduino booklet and solving easier problems with similar components. This allowed us to learn from our prior mistakes and to apply new concepts. For our next project, as a group, we will try and come to a goal state in a much more timely manner, whether that be a specific idea or a concept. As far as working with Arduino goes, we will not do as much trial and error with our design ideas. We wasted too much time by not following basic principles in order to solve more complex problems. Perhaps our most significant find throughout the process was how limitless the possibilities really are. The number of things we could have done, or do, is far beyond what we could accomplish in the time of a couple of weeks.